Well, hello again. We're ready to start section 5 of chapter 1, titled The Complex Numbers. Now, I know what you're thinking. You're thinking complex numbers have always made me feel like this. Very, very sad. But I can guarantee you, if you work hard and you take good notes, then after this section, complex numbers will make you feel like this. And who wouldn't want to feel like that guy, my son, Jake? So, that being said, let's begin. Complex numbers, i.e. imaginary numbers, go by the imaginary unit I. We say that because 3 squared equals 9, that the square root of 9 is 3. That's easy enough. Because 6 squared is 36, we can say, alright, well then the square root of 36 is 6. Because I squared is equal to -1, which you should have a big fat star by and get memorized right now, then we can say that the square root of -1 is what? Well, it's I. Alright, cool. Now, if A is some number that is positive, it's bigger than 0, okay? Then we say that the square root of -a, whatever that number is equal to the same as pulling out the imaginary unit I, the negative comes out as I times the square root of a. For example, if you were to take the square root of some number -3, don't type it into your calculator, just recognize that the negative becomes the imaginary unit and you still have the square root of 3 on the inside. Let's do a couple quick examples here. If you had the square root of 2 times the square root of 3, they're both inside of a square root, so they can multiply and get the square root of 6. But if you have the square root of -2 times the square root of -3, that up until this year you've always been told a negative times a negative is a positive. And that's true, but in this case it's not equal to the square root of +6 because of the order of operations. You must take the square root first. So, as a rule, the square root of some number a times the square root of some number b, that's supposed to be b right there, is equal to the square root of their product, ab. Okay, but that's only if a and b are greater than 0, if they're positive numbers. Alright, you with me? Now, what you could do on that last example that I showed you where it was not equal to the square root of +6, let me go back to it. I'll switch colors. The square root of -2 times the square root of -3. It's not equal to the square root of +6, but what you could do is, alright, take out the negatives as the imaginary unit, so you have I radical 2, another way to say square root is radical, times I radical 3. Now, multiply the outside numbers. I times I is I squared. And multiply the inside numbers. 2 times 3 is 6. It's still inside of the radical. I squared, though. Wait a minute. Dun, 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 dun. I told you to put a star there. What's I squared? It's -1. So this is really just negative radical 6. Okay, so we're going to do a bunch of examples now involving imaginary numbers or complex numbers. I'm going to go rather quickly, but feel free to pause the video or stop the video. I would also recommend maybe after each example to pause the video and then go back and try that example again on your own. So, number 1, part A. In all of these you're going to simplify. And in this first one you're going to simplify the square root of -5. Well, you have, let's see here, the negative on the inside. And what did I tell you? The negative always comes out as a complex unit. Now, you could also, if you wanted to, think of this as the square root of -1 times the square root of just 5. That's okay. But remember, the square root of -1 is just what? That is I. Now, if you wanted to skip that middle step, I completely would understand. Try the second one. The square root of -36. Well, the negative comes out as the complex unit. You're left with the square root of 36 on the inside. But 36 is a perfect square. The square root of 36 is just 6. So this really just says 6i. Alright, and finally, try this one. This one's a little bit more saucy. The square root of negative 16 minus 2 times the square root of negative 49. Just simplify it one at a time. The square root of negative 16, the imaginary unit comes out, and you're left with 16 on the inside, minus 2 times the imaginary unit comes out right here from the negative. You're left with 49 on the inside. Okay, 16 can break down to 4 times 4 because the square root of 16 is 4. That just becomes 4i. The square root of 49 is 7, so you're left with, that's 7 times 7. He gets out, he dies. He now gets to play with the 2 because he's on the outside. Multiply them, that becomes 14i. Now, these are like terms, and like terms can be combined. 4i's minus 14 i's is negative 10 i's. Check it out. There you go. So this big, nasty mumbo-jumbo just becomes that. Well, that's pretty cool. We define complex numbers as any number that takes on this form, a plus bi, where b cannot equal 0. Otherwise, the complex unit wouldn't even be there. Some examples. 3 plus 2i. Okay? 4 minus 7i. That's an example. Here's a nasty one. 1/4 minus 5/2 I. Here's another one. 0 plus 6i. Which, by the way, is really just 6i. Okay? Here's another one. I square root of 7. Anything with an I is a complex number. And if it doesn't have the constant coefficient out front without the I, that means there's really just a 0 sitting there. Now, a real number is defined as a plus bi, only what do you think b has to be for a real number? Well, it's got to be 0, because for a real number, the I is not there. Actually, you'll learn if you take an abstract algebra class in college, which I know you all will because you're going to be math majors, of course, you'll learn that the real numbers are actually contained within the complex numbers. Up until now, you've probably thought it was the other way around. But the real numbers are actually inside the complex numbers. Pretty crazy. So, examples of real numbers. 0 is a real number. Negative 7 is a real number. The square root of 29 is a real number. Anything without an I. 1/10. Pi is a real number. E is a real number. Anything without an I is a real number. So let's do a couple hairier examples, shall we? Let's simplify 3 times the square root of negative 12 and add that to the square root of negative 27. Clean that up. Now, you know it's not simplified because there are still negatives inside the radical. Now, remember, the negative comes out and becomes an I. So we have 3 times I, and the square root of 12 is still inside the radical. Over here, you just pull out an I, and the square root of 27 is inside the radical. Now, you may be finished here, but you'll remember from Algebra 1 and Algebra 2 that sometimes you can break numbers out of jail. I call the square roots, I call those jails. And to bust out of jail, you need a twin. So 12 is really 4 times 3. And then you can bust 4 down to 2 times 2. Do you see any twins? Well, you do. Circle one of the twins, and sadly, the other twin must die. He's gone. Let's just say he got killed trying to bust out of jail. Alright, the 4 doesn't matter anymore because you broke him down. The 12 doesn't matter anymore because you broke him down. But the 3, he's a bum. He doesn't have any friends, so he has to stay where? He's got to stay in jail. Alright, so that 2 gets out. It plays with the 3 that's already out. 2 and 3 make 6. Now you've got an I, and the 3 was the bum still inside of jail. Do the same thing with the 27. It becomes 9 times 3, and then 9 can break down to 3 times 3. You got twins. Circle one, slash the other. The third one, he's a bum because he doesn't have a twin. The 9 doesn't matter. The 27 doesn't matter. A 3 gets out of jail. He doesn't have anybody to play with, so he sits with the I. And then this 3 that you underline, he's the bum. He's still in jail. Now, if the numbers inside the jails are the same, guess what? These are like terms, and you can put them together. 6i square root 3 plus 3i square root 3. Add your 6 and your 3. That's 9i times the square root of 3. Check it out. Very cool. That one's now finished. No more negatives inside the radical, and no more breaking down that you could have done. Here, let's try another one. 5 times the square root of negative 4 plus 9 times the square root of negative 8. Simplify that as far as you can. Alright, well, let's take a shortcut here with the negative 4. Hopefully by now that should be getting pretty easy for you. That is really just 2i. The square root of negative 4 is really just 2i. And 5 times 2i becomes 10i. Sweet. Alright, let's take a look at the 8. Break him down. He's not a perfect square, but he's got perfect squares as factors. 8 breaks down to 4 times 2. The square root of 4 is 2. So that 2 will play with this 9 right there. That becomes 18. The negative breaks out, becomes an I. Alright, very cool. And then who would have been the bum left inside the jail? Who was left over? There was a 2 left over when you broke down the 8. Now, that is technically correct. You could, if you wanted to, you could factor this out so that there's only one I and leave your answer as 10I times 10 plus 18 radical 2. And then this big nasty number over here you can think of as the coefficient b, where your a is just, you can think of it as plus 0, and that would be your a. Remember how I said that sometimes a is 0? Well, the b here in this case is that big nasty irrational number, 10 plus 18 radical 2. But welcome to big boy math, boys and girls. Sometimes it just gets nasty like that. Alright, let's do some more examples. Okay, so we just did some pretty difficult ones. Let's do a couple warm-up problems to take it easy for just a couple of them. 2 plus 3i plus the quantity 4 plus 6i. Alright, now when you're adding two quantities, just look for like terms. 2 and 4 make 6. 3 i's and 6 i's make 9 i's. Can't do anything else with that bad boy. He's done. He's finished. Alright, let's try the next one. Do the quantity 3 plus 6i minus the quantity 7 minus 12i. Now here you got to be careful because you're subtracting a quantity, so you need to remember to change the signs because you're subtracting. You need to change the signs of the 7 and the negative 12. They will become, leave the first quantity alone, 3 plus 6i, but that 7 becomes minus 7, and that 12i becomes plus 12i. And now just combine like terms. So 3 and minus 7 are negative 4, plus 6 and plus 12 is plus 18i. Can't do anything else with that. You're done. You're finished. Okay, so we did an addition, we did a subtraction. Let's do a multiplication one. Let's do the quantity 2 plus 3i times the quantity 4 plus 5i. Excellent. Alright. Ooh, boy. Well, this one, you would use FOIL. Or, I like to just call it the distributive property. Multiply the firsts. 2 times 4 is 8. The outers, 2 times 5i is 10i. The inners, 4 times 3i is 12i. And then the last, careful here, 3i times 5i is 15i squared. Now go back to the beginning of your notes. What did we say about I squared? Oh, wait a minute, that's really just negative 1. That means this whole thing right here really just says what? This really just says minus 15, because it was 15 times negative 1. And now combine your like terms. 8 minus 15 is negative 7, 10 and 12 plus 22i. And there you go. So this nasty hunk of junk becomes negative 7 plus 22i. So what I want to do now is show you how to actually work with complex numbers on the calculator, on one of these TI-83s or TI-84s. So you turn them on by hitting the on button right here. And then what you can do is you can tell your calculator that you want to work in complex number mode. See this mode button right here? Hit the mode button. And you want to go down. I'm using the down arrow right here. And I'm going over where it says real. I want to go over to A plus BI mode. So I'm just going to hit enter down here. So hit enter, and now you can hit second quit to get out of there. Now we're going to do the example that we just did, the FOIL one. But this will work for any of the examples we've done so far. I want you to type parentheses 2 plus 3, and then I, where is I? Oh, I is right above the decimal point. So you have to go up and hit second, and then hit your decimal. And then close your parentheses. So right there, we have 2 plus 3i. It's kind of tough to tell, but it's there. And then type the second quantity. That's 4 plus 5, and then hit second decimal point. That's your I. Close your decimal. And then, drum roll, hit enter. Dun 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 dun. Looky there, negative 7 plus 22i. So that's kind of cool that your calculators will do that for you or with you. So let me get that out of your way. Let's do a couple more examples. Okay, letter D here. D is 7 plus I times the square root of 5 times 7 minus I times the square root of 5. Alright, so do FOIL. Why don't you guys try this one on your own? Pause the video, try it on your own, come back, see how you do. Okay, do your first, that's 49. Do your outers, that's minus 7i root 5. Sometimes I just say root 5 instead of square root 5, it's faster. Inners would be plus 7i root 5. And then last would be minus I squared. And root 5 times root 5 is root 25, which takes you right back to 5. So here's a shortcut. Root 5 times root 5 is just 5. Basically, the 5 gets out of jail. Alright, so cross out your middle two guys because they just cancel. I squared, remember, really just said is negative 1. Well, that means this whole junk right here just says plus 5. That's all it says. So this really just says 49 plus 5. The answer is 54. And that's it. Isn't that crazy how you start with two complex numbers and you end up with a real number, 54. Try it on your calculator. I guarantee you that'll happen. Okay, letter E. I didn't have room on the last screen. Letter E says this. It says the square root of 3, this is all in a quantity, plus 4 times I square root of 2 times 3 plus the same thing, 4i square root of 2. Alright, oh, by the way, this is supposed to be the square root of 3. So do the same thing, do your FOIL, and see what happens. Now this one gets pretty nasty. There's a lot involved here. Your first, remember, what's the shortcut? Root 3 times root 3 is just 3. That's the shortcut. You need to have that memorized. Okay, root 3 times 4i root 2, the roots play together, and the numbers on the outside of the roots play together. So this would actually be 4i root 6. The same for the middle guy. That would be 4i root 6. And then for the last guy, you have 4i times 4i, that's 16i squared. If you want to take a shortcut and put negative 16i, that's fine. Or I'm sorry, just negative 16, that should be I squared. And then root 2 times root 2 is just 2. The 2 gets out of jail. All right, let's clean this up a bit, shall we? This is 3 plus. Now, the middle two guys have the same roots, which means the outsides of those roots can go together. They like each other. 4i's plus 4i's is 8i's. Those are called combining like terms. Root 6 doesn't change because you're not multiplying. Over here, this is 16 times 2, which is 32. And I squared, which is what? It's negative 1. So that really just says minus 32. Let me erase this plus sign. Put minus 32. Now, can you finish this up? Can you do anything? Yeah, you can combine 3 minus 32. Answer, minus 29 plus 8i root 6. And again, if you type that into your calculator, it would pop out just like that. Actually, no, it wouldn't, because I don't think your calculator leaves answers in terms of root 6. So it would be the decimal equivalent of 8 times root 6, whatever that is. Okay, last example here, and I think I'm going to call it quits for this video. Here's example number 5. I want you to multiply the root negative 3 times root negative 6. Clean that up the best you can. All right, well then, are you allowed to just multiply negative 3 and negative 6, yes or no? No, I showed you earlier that those numbers have to be positive to multiply them, or at least just one of them positive. But if they're both negative, you can't. But what you can do is pull the complex unit out on both of them. And now you can multiply the complex units. So that's I squared. Now you can multiply the inside. So that really just says negative 1 times the square root of 18. And you might be done, except maybe 18 breaks down. And it does, to 9 and 2. The square root of 9 is 3, so one of those threes gets out, and the poor 2 has to be the bum that stays inside of jail. Again, you can check this on the calculator, but the calculator is going to give you the decimal equivalent. It's not going to give you the answer in terms of radicals. So I think that's all I'm going to do for the first half of section 5. But be looking for the second half of section 5 to show up pretty soon. Hey, have a great day, and I'll talk to you later. I'm out.